Unit 4 Chemistry, Chapter 10, Part 3. We're looking at more functional groups, but these are ones for the molecules you don't have to name. Okay? What you do have to be able to do is identify the functional group and essentially be able to point at it and go, there it is, that's an ether, or there it is, that's a ketone. You also need to know the properties. Okay? So, our first one are the ethers. Now, it's a simple little functional group, and don't get it confused with esters, even though it's similar. It just goes carbon, oxygen, carbon. Okay? These are groups that are found in carbohydrates. Okay? Some of you may, if you've looked at them in carbohydrates, call them glycosidic bonds. A glycosidic bond is a subgroup of an ether. So all glycosidic bonds are ether bonds, but not all ether functional groups are in glycosidic bonds. Okay? They're non-polar, because even though this oxygen is electronegative, it's symmetrical and you've got hydrocarbon chains on both sides. So essentially the overall molecule ends up pretty much non-polar. Second one you have to be able to identify is the amide group. Similar to the amine, but you'll find that it has a C double bond O on either side. Okay? You may also find that it doesn't have an NH2. You may find that instead of one of these hydrogens, you have a hydrocarbon chain which is continuing on this side. Okay? So the amide group contains that oxygen, that carbon, that nitrogen, and one of these hydrogens. Just one of them. These are found in proteins. Again, similar to the glycosidic, you might have heard this called a peptide bond. In the same manner, peptide bonds are just in proteins. So all peptide bonds are amide links, but not all amide links are peptide bonds. Okay, it's just a subgroup within them. Okay. The other one we'll find is the ketones. Now, ketone is just a carbon double bond oxygen in the middle of a chain. Okay, they're fairly reactive. Okay, and if we've got a secondary alkanol and we're going to oxidize it, this is what we're going to end up with. Okay. The similar one to that is the aldehyde. Now, an aldehyde is also just a C double bond O, but it's on the end of a chain. Okay, so technically would include the terminal or end hydrogen in that functional group as well. Okay, so this bit in the end, that's your aldehyde functional group. Okay, these ones can also be oxidized. Okay, they can be oxidized much more readily and they can get turned into a carboxylic acid.